So what Rolle's theorem tells us is that if we have this graph here and the average rate of change between these 2 points is 0. So if we drew a line from there to there, the slope would be 0. Then that means at some point on this curve, the derivative must be 0. And that makes sense because if we look here, this line, the slope of the whole line is 0. If we go up here, if we do anything other than just going in a straight line, we're going to need to go down and then back up, or up and then back down. So either way, at some point, in this case, for this graph, it's this point, the slope is 0 because it's changing direction. And here it's this point because the same reason, it's changing direction. So any curve with these 2 points as endpoints, if it's continuous, must satisfy the condition that there's a point somewhere on this curve in between those 2 points with a slope of 0. And the mean value theorem is essentially just saying the same thing, but generalizing it to anything, so something that's not 0, just a flat line. So here we have a curve with a secant line, which is the average rate of change between these 2 points. So this is the slope of the line between these 2 endpoints. And because the graph comes up and comes back down, at some point, at this point, the point up here with the tangent line, there has to be some point where that has the derivative that's equal to this slope. And that's just because if you go up, you have to come back down to make sure that you get from between these 2 points. So conceptually, that's not too bad. And you'll just have to, when you answer a question, you'll just have to say, oh, if the endpoints have this slope, then there has to be some point between those that has that slope. So that is a derivative.